Okay, so the last example in section 5.5, dealing with the substitution rule, is going back to this integrals of symmetric functions. If f is continuous on the interval from negative a to positive a, and f is an odd function, which means if you plug negative x into the function, you get the opposite of the function, then the integral from negative a to a is equal to 0. And so really you have to understand what an even and odd function is. And so since f of x equals the tangent of x satisfies f of negative x, so if you plug negative x in, you end up with the opposite of the original function, f of x, which means it's an odd function. Then, if we want to evaluate the integral from negative 1 to 1 of the tangent of x dx, that's just going to simply be 0, right? So you have to determine if you're looking at an even or an odd function. So you may want to take a moment to go back over what even and odd functions are. And once you know if it's an even or odd function, you can use this property here. If it's even, right, something like this, going back to example 9, right, this is an even function. How do you know it's even, right? If your function is f of x equals x raised to the 6th power plus 1, right, you plug negative x into the function. That's going to be negative x raised to the 6th power plus 1. Well, if you take any negative number and raise it to an even power, that's going to give you back a positive number. So that's still x to the 6th power plus 1. You get back the original function, right? In our tangent function, the second example, we have f of x equals tangent of x, right? And you plug a negative value into that function. So let's say negative pi over 4, just to actually give you a specific number in this case. So that would be tangent of negative pi over 4, which equals negative 1, right? So this works for any x. If you plug a negative x value into the function, so that's tangent of negative x, you end up with the opposite of the tangent function, right? And so that's an odd function. And so just go back over those definitions and be able to apply these two properties.